Today we will be talking about venomous species and in particular about snakes. This is actually a video response to a video made by Derek from Veritasium a few days ago, and he was asking, like some other people, why it looks like that venomous species are more common in hot countries. I really think you should check out the original video over here, it's really cool. Derek starts off the video by showing a map which shows the hot areas on this earth and the cold ones, and then he also made a map indicating the number of venomous species per country. However, the problem with this, the data is not normalized for the total number of species found in each country. Because the general trend from the poles to the equator you will find more and more species, so the biodiversity is increasing. This of course is not the case for all regions, so in the desert you won't find so much animals, but it's a general trend. As Derek later points out in the video, there is no real trend with temperature and the number of venomous species found in a country. However, I still would like to criticize some problems with this approach. One big issue is the counting by country borders. If you just count the number of venomous species inside one particular country, because the distribution of a species goes across the borders of countries. If you want to find a trend in the distribution of venomous species, you should rather look at climate zones. So as you see here on the map, you have the tropics and deserts and tundra and so on. And most of the time, species have a specific habitat that lies somewhere in those regions, or you might even want to break it down further in more detail. By looking at those climate regions, you might be able to find a trend at all. I'm not sure if someone has really done this, but I think it might be worth a try to do some research. I think the biggest challenge if you want to do some research on this would be to get reliable data, and also you need to have quite a lot of data. Another problem is if you count the number of different species, I would say you rather should take a look at the number of independent evolutions of venomous species. For example, if you have one snake and it evolves a very strong venom, it might have an advantage compared to other non-venomous snakes. Our one venomous hero snake will flourish and expand its range across a big landscape, and then it might happen that this species actually splits into several species if you differentiate into different niches and you have some evolutionary factors going on. So this could have happened a few million years ago or even longer, and today we take a look and we find 5 snake species who have all evolved this venom, but in fact it was just one ancestor species. So we really should take a look on the relatedness of the venomous species and see if they all have one common ancestor, because then I would rather count them as one and not like 5 different venomous species. Because once you have evolved a venom, it's quite easy to radiate and to split into different species. I would take a look at the species histories and look for points where the venom has actually evolved. This way we might be able to find some ecosystems where venomous species are more likely to evolve, and we can find the mechanisms that lead to those evolutions more frequently, if there are any at all. In the last part of the video, Derek is talking with some expert about snakes in Australia. They were wondering why some snakes are really venomous, so if you get bitten, you're very certain will die, and some are just not so much venomous. So if they bite you, it hurts, but you will survive for sure. So how can it be that some snakes are very venomous and some others are not, and they live in the same area? I think that the snake and predator interaction could be the answer to this question. We have here our venomous snake and its predator. Let's just assume it's a fox, for example. And now they will engage in a dramatic fight, and there are basically 2 options. The venomous snake will manage to bite the fox and the fox will die because the snake is very venomous, or the fox will eat the snake. But if we now take a look at the same situation with a snake that is not very venomous, if this one bites you, it just hurts a lot. It can go 2 ways again. First, the fox can still eat you because you as a snake are not skilled enough to defend yourself. But if you are a very good snake, you might be able to bite the fox. Now the fox will be in a lot of pain, but hey, it will survive. But I think foxes are quite clever, so this one fox that you have bitten, he will we for sure remember that you are a very nasty snake. To attack you, it can result in a lot of pain, so I think maybe next time he will avoid you. So by not killing off your predator, you can introduce some kind of learning effect into our fox. I think after a few engagements, the fox will very quickly learn that it's not worth attacking you as a snake. The big problem is, however, if you are very venomous, that the fox has no chance to learn. He will eat you or he will die. Of course, a lot of factors play into those interactions, and this is dramatically oversimplified. If this system works for you as a not so much venomous snake depends of course on your predators. And it even could benefit you as a non-venomous snake, because some predators might avoid all snakes and not differentiate between different kinds of snakes. The next strange thing was, why would a snake that is venomous actually lose its venom and became a non-venomous snake? Because you would think it's kind of advantageous and you don't have a lot of cost producing the venom. So why would a snake evolve this way? Because I talked in the video about how a lot of snakes in Australia are now non-venomous but had venomous ancestors. I think the answer to this problem is relatively simple. You can afford to lose your venom if you don't have the problem with predators. Or maybe you change your behavior or your home range, or you change some factor that allows you to survive even if you are not venomous. This could be the case, for example, if the predators around you avoid all snakes completely because of your venomous friends. However, it's not like snakes choose to not be venomous anymore. This of course has to evolve. And the thing with venom, even if it's not very costly, you still need to produce your venom. And for that you need a blueprint, like a cookbook that tells you how to make this delicious venom. And every snake is very lucky to have blueprints to produce the venom, and this is the DNA. I would assume that quite a lot of different enzymes and pathways in the cells are needed to create those venoms. And the big problem is that if something in the pathway mutates, that you can't maintain the pathway anymore. So it's kind of an error in your protein and stop working. So if you have a mutation on the wrong point in your DNA, you will lose your venom. This is kind of a problem if you really need your venom, if you have predators that are attacking you and you really need to be a venomous snake to defend against them. However, if you don't have this pressure, if you don't have the pressure by predators or some other factors to really keep your poisonousness, mutations in genes responsible for your venom pathways will really quickly lead to a non-venomous snake. So those were just some ideas, some hypotheses that might explain the patterns we find. Or maybe I'm completely wrong, I'm not a snake expert. But make sure to let me know in the comments below what you think about it, or maybe post your own theories. As always, thanks for watching, I see you next time. Bye bye! Next week I will be talking about dinosaurs and why they went extinct. However, I can only do this if I get behind the paywall of the magazine Science, because there was a nice paper published a few days ago and I need to see if I can get a hold of it somehow. So, until next week, bye bye!